Welcome to Unity Game Development Session 2. If you guys remember in the last session, we did a quick little introduction on what Unity is, and then we went over how to install Unity. In this session, we'll go more in depth about Unity. We'll be discussing the, at first, kind of confusing Unity interface, but really the interface is very, very simple when you really understand it. As usual, this is made by Decode STEM. And without further ado, we can get started. So this Unity tutorial is broken up into three sessions. The first session is Intro to Unity, which is around 12 minutes, which was the session, the previous session. The second session is part one of game development. This is our current session. In this one, we want to start creating our first game, which will take around 20 minutes. I also want to explain to you how the Unity interface works, how to manipulate objects, and how to get your first program running in Visual Studio Code using C#. The third session is going to be part two of game development, and this will just finish up creating our first game. We'll add the final touches, we'll add the loading screens, we'll add the pause screens, we'll add all those screens, all the little details, and this will take around 30 minutes. But without further ado, we can go ahead and get started, and let's make our game. So I'm back here in Unity from the project that I made previously. It's in test project. If you guys are confused on how to make your how to get your game back up, if you go to the Unity Hub, you should see the project that you made right here. In this case, I called it test project, so you can go ahead and just click it, and it should be pretty easy to just find the project right there. So once your project is up and running, there are a couple of things that we need to understand first before we even start scripting or before we even start creating levels. Unity is kind of split up into a multitude of tabs. We have this hierarchy tab right here. We have this project tab right here. We have this scene view right here. We have this game view tab right here. And then finally, we have this inspector tab. At first, this may seem kind of confusing, but once you start to understand it, it'll really start to piece together and make sense. Step by step, the hierarchy tab is essentially where all your assets are. For example, if I have 1,000 cubes in my scene view right here, they'd all be located in my hierarchy right here, so I can see each individual cube. The hierarchy is especially useful when your levels get more complicated because you can have multiple trees and you can have multiple bosses, you can have multiple players, and in that way you can kind of group your certain things together, and you can group them in a way that makes sense to you, which allows you to design your level more efficiently and it's more organized. The next thing to kind of note is this project tab down here. Essentially what the project tab is, it's where all your assets are located. If you guys are unsure on what assets are essentially they're essentially designs, or they're essentially files that are part of your game. For example, common assets include players, objects, materials. It all really depends. Assets can be anything, but anything that you kind of see in this scene view are considered assets. Obviously, we don't see it over here because all we have in our assets right now is just a folder called scenes. And if you guys are confused what this folder is, if you click it, it's literally this sample scene right here. So Unity is split up into multiple scenes in which you can have multiple scenes in one game. For example, if you want to switch levels entirely, it's effective to use one or two scenes. So you have this scene, which is my sample scene, which is what I'm using right now, and then I can have another scene. I can have another scene that I just named new scene right next to it. The advantage of having multiple scenes is that it makes it easier to navigate. If I reach the finish line, for example, I can be like, take me to this new scene. And if I open up this new scene, it opens a completely different completely different scene view where everything's erased. But I can always go back to the original sample scene by just double clicking it. And that's kind of the power of scenes, is that you can have multiple scenes in one game and you can switch between scenes. So especially useful if you want to make kind of a level changing mechanic, or if you're changing pages, or if you have a loading screen. And that's kind of the power of scenes. In my assets, I can also have a multitude of other stuff. For example, a common thing that a lot of developers like to do is take assets from the Unity Asset Store. The Unity Asset Store is essentially a store which creators can publish materials or publish objects that they made, and they can allow other game developers to use it for either money, or it's oftentimes free of cost. So game developers can just take these assets from the asset store and just import it into their folder, and you'll see this here in the project view. So your project view is just essentially all the files that are corresponding with your game. Next to the project view, you might see this little thing called console. Yeah, so the console is essentially for debugging. And we'll talk about this more when you start scripting, and it'll make sense then. But all you should know right now is that the console is not the most useful, but it can be useful for debugging. And we'll actually try that in a bit. The next thing to note is your scene view. We talked about last how to move around and navigate around the scene view. Talked about pressing Alt and left click and dragging around. You can look around like that, or using your scroll wheel to zoom in and out. But essentially, what your scene view is this is where what your scene looks like, and this is what your level looks like. On your game view, in contrast, is what your game actually looks like. For example, if I press this play button right here, which is a play button to mimic actually playing your game, you should see the game view highlight, which shows and indicates that we're looking at the game view right now. And this is how the player would see the game. And that's essentially what you want to keep in mind whenever you're making games, because the scene view is important because it allows you to look at your scene and modify levels and go underneath grounds and modify it and whatnot. But your game view is that actually matters because that's what the player sees when they actually play the game. The final thing to note is the inspector. The inspector basically contains a multitude of different properties of a certain object. For example, if I click on this cube, you can see all these properties. And while at first it may seem confusing, it's pretty simple. The main thing you need to know about the inspector is this thing called a transform. What the transform essentially does is it allows you to manipulate the position, rotation, and scale of the object that you have clicked on. For example, if I have this cube right here, which you can see in the scene view highlighted, if I'm clicking on this and highlighted this, what I can do with this transform is I can modify these values, the X, Y, and Z values, to change it to whatever liking I want. Let's say I want to make the position of this to 1. You can see that in real time and in the scene view and in the game view, my cube moved to the X position of 1. But if I wanted to make my Y position 1, I could also make that 1. If I want to make my Z position 1, I could also make that 1. Um, the transform is usually used when you want to access the position, rotation, or scale through code. Usually, when we want to move things in the scene view, we can usually just move it using these arrows right here. It's just much more efficient. But you can obviously use the transform. That's kind of the whole point. One big thing that a lot of people like to use the transform for is changing the scale. Like the name says, the scale just scales up or down the respective object. For example, if I wanted to make this 2 times as big, I can change every value to 2, and you can see I have a larger cube here. And that's kind of the power of Unity. Mesh render and box glider, they aren't too much of a worry right now, but essentially a mesh render allows you to actually see the cube. For example, if I turn it off, you can see that I can't see anymore. And the box collider is a collision system that Unity has built in, which we'll talk about more. Okay, so now that we've gone over the basics of Unity and how what everything kind of means, now we can go into the actual scripting. So to create a C# script, what you need to do is you need to right click here, click create, and click on C# script. And we'll name this test script. So if you don't already have Visual Studio downloaded, you should download it. When we installed Unity, we also installed Visual Studio. So it should already be there, but if it isn't there, then make sure you install Visual Studio and connect it to Unity. But once we have created our script, we can go ahead and open it up by double clicking on it, and it should say Microsoft Visual Studio right here. So we've opened up test script in Microsoft Visual Studio, and if you aren't familiar with languages like C or C Sharp, this may seem kind of intimidating at first. I promise you it's not that intimidating, and it is a little bit different than languages such as Python, just because a C Sharp is not dynamically typed, which means that the variables are often classified or declared at the beginning, and they're manipulated via code in the update method, for example. But to start off pretty simple, most languages have something called a print statement where you print something and in the console it shows you what you printed. In Unity, however, we have something called debug.log. Debug.log. So what essentially debug.log does, it essentially does exactly what print statements do. It just prints out whatever you want to print out in the console tab. And that's exactly why the console tab is there. As mentioned before, it's used for debugging, and a lot of the times how people debug in Unity is by using these print statements. So they can check at each stage of the game if this is working, then debug.log it's working, for example. And we can actually do that. If we wrap it around quotes and say it's working, and then end it with a semicolon. Always end it with a semicolon. That's something that is shared among a lot of languages, but especially in C sharp, you will always get an error if you don't end it. For example, it says, yeah, semicolon expected. So just end it with the semicolon. And if you click debug.log, it's working, and with quotations around it because it is a string. And then you save it hitting Control S and go back to your Unity. It should automatically reload script assemblies, but you may see that in the console it's not printing over here, it's working. And the reason why it's not printing it's working is because we haven't attached our script to anything. Right now our script is just a standalone script, so it doesn't know what to do. However, the way we attach scripts is by attaching it to objects. And in this case, since our cube is our main object, I guess, we can go ahead and attach it by simply dragging it and putting it over add component. Alternatively, you can also just click on add component and type in test script. That also works, but either one works. But now that we actually attach our script to an object, now the thing actually should work. So if we go ahead and click play, we go ahead and see it's working right here. And this is kind of the first step of scripting in your scripting Unity journey. So now that we got our first little piece of code working and we can see in the console, we can go ahead and click on play. Let's go back to Visual Studio and let's kind of run down what's going on. At first, you see all these using systems collections. Systems collections are generic using Unity Engine. These are what we like to call namespaces. Usually, we don't really interfere with these. These are just always automatically in every single Unity script, and we just keep it as is, just because it allows us to access the Unity Engine API. Um, the next thing we have in our script is this public class test script. This just contains the name of our script, and all of this don't matter too much, but what does matter is this void start and void update. What void start essentially is, and if you work with Arduino, you would know what this is. But what void start essentially is, it's a method that gets called at the start of every time you press play. So because I put debug.log, it's working in this void start method. When I click play, it went ahead and printed out it's working in the console. However, the void update, on the other hand, runs the code given once every frame. So all of your movement code, all of your code about like mechanics, all of your where you're doing actually doing something, your action code should almost always be in the update, right? And if I actually debug.log, and it says right here in the comment, update is called once per frame. So every frame, this code will be ran. So if you ever want to have like a movement script, for example, you'd always want to put that on the update because you don't want to just move once because the start method just does it at the start and stops it right there. But the update method continuously does it as long as your game is running. If I go ahead and debug.log the same thing, it's working, semicolon, don't forget that. And I press Control S or save it and go back to Unity. If I click play, you'll see that because it gets called once per frame, it's debugging the log once per frame. It's working, it's working, it's working, it's working, and it's continuously doing that. And you can actually see right here, it's over 1,000 because it's once per frame. So as many frames as you have, it's doing it once every frame. And that's kind of the power of Unity because you can have something at the start. For example, I can, if I wanted to debug log start method test. I go ahead and save that, you can see how they kind of work together. Um, I'm going to go ahead and stop that because otherwise it's going to go on to 1,000. But if I scroll up, you can see that at the very beginning, it printed out start method test. And that's because in my void start, I debug.log start method test. But then after my void update, which is called once per frame, I told it to debug.log it's working. So once per frame, it debug.log it's working, it's working, it's working. And that's kind of the difference between the two methods. What's cool about debug.log is that you can also print out not only strings but also just integers, for example, or floats. For example, if I wanted to print out the position that the cube is at, I could just debug.log this dot transform dot position. And if you guys are confused on what this dot transform dot position is, this essentially what this does is it takes the attributes of whatever this script is attached to. And since the script is attached to this cube right here, it will take the attributes of this object right here, which is the cube. The next thing to realize is this dot transform dot position. The way we access certain components, for example, the transform component, is by using the dot operator, which allows us to kind of access certain attributes that are part of a component. Let's say, for example, I wanted to access this transform component. The way I would do this is by using this, which is locating the object that this script is attached to, hence this dot, using the dot operator, transform, which is the component right here, dot position, which finds the position of the cube. And this code is pretty simple. It's pretty self-explanatory. If you go ahead and click Control S and go back to Unity, click play, it says a position right here. 1.85, negative 3.77. So you may be confused why it's 3 position. And the way that Unity works, and since this is 3D, is that we have 3 different values. We have your X value, this way. You have your Y value, which is this way. And you have your Z value, or Z value, which is this way. And since this is 3D, we have 3 different dimensions. So if you want to print out the current position, it prints out the current position. It prints out the current X, Y, and Z position because it's 3 dimensions, right? It's a vector. It's not just 2D. It's 3D. That made sense. I know we didn't do much scripting, but I really just explained the basic process of what Unity is and how it works. But in the next session, we'll go more in depth to the scripting now that you've got the general layout down, and we'll talk about how we can make our first game, especially our first movement involving game. So, in conclusion, what we went over is that I explained the general layout of how Unity works with the project hierarchy, game view, scene view, all of that. Then we created our first script in C# using the debug.log, which is once again is similar to the print statement in other languages. And then finally, using the debug.log, we printed the current position using the transform.position and the dot operator specifically, and using the transform component. In the next session, we're going to be talking about how we can actually create movement. We'll be talking about how you can use different components and how you can add components, like the rigid body component, for example, if you want to do a little research. And then finally, we'll do some in-depth game design, how to change textures, how to change materials, and how to actually design a level. Thank you for watching, and I hope you guys come to the next session. Bye.